In this lesson, we're going to be talking about the components of the refrigeration cycle for air conditioning. Now, remember, just a refrigeration system or an air conditioning system moves heat from a space where it's not wanted to a place where it makes little or no difference. In other words, we don't want the heat inside the building, but it doesn't matter if it's outside the building. So we need to move that heat from inside to outside. We have four major components that make up a refrigeration system, or a vapor compression system, sometimes as it's known. We have a compressor, we have an evaporator, we have a condenser, and we have a metering device. The compressor, it's called a positive displacement pump. Okay, it creates a pressure differential required to absorb the heat in the evaporator and reject it in the condenser. In other words, it's a vapor pump. Okay, it takes low pressure vapor, it increases the pressure, and discharges a high pressure vapor, sort of like an air compressor. Okay, the condenser is our next major component. It's a component where heat absorbed in the evaporator, as well as the heat of the compression, is rejected into the ambient air or water. Okay, it's basically pushed out of the system. The refrigerant enters the top of the condenser as a superheated vapor, high temperature vapor. As the refrigerant loses heat, it changes state from a vapor to a liquid. Okay, this is an example of a typical condenser. We're pulling air. The ambient air surrounding the condenser might be 95 degrees. The air blows across the condenser coil, which is hot, okay, and the air absorbs heat out of the hot condenser oil and then might discharge from the condenser at 130 degrees. Okay, remember, heat always moves from an area of higher heat to a lower heat. That's why, for example, when you put a hot cup of coffee on a counter, the heat will leave the coffee and go into the air surrounding it. Same principle occurs. Heat always moves. Heat is energy. It always moves from a high temperature to a lower temperature. The metering device is the device that regulates the flow of refrigerant into the evaporator. Okay, it sets up a pressure differential between the high inlet pressure and the low pressure in the evaporator. The pressure difference is what begins the refrigerant boiling process. Think about the metering device as your finger over the end of a garden hose. Okay, the hose has a high pressure water in it. So what's spraying out once it's out of the hose around your finger is a low pressure water stream. Okay, that's exactly what's happening in the metering device. Okay, there's a couple examples of metering devices. We're going to talk more about them as the course goes on. The one on the left, okay, is a capillary tube used in smaller systems. The one in the center is the AEV or AXV, okay, mainly used in refrigeration. The one on the right is a TXV. That's the one you're going to see most often in our high efficiency systems of today used in air conditioning. The evaporator is my final major component that has to be there. Okay, it's the component where heat is absorbed from the ambient fluid, could also be air. Okay, the refrigerant enters in a liquid state, boils off or evaporates, turning into a vapor, absorbing heat as it changes state. Anytime we boil something, think about a pot of water on a stove, think about anything we boil, it takes heat to do that. The same thing is happening in the evaporator. It takes heat to boil off that refrigerant. The boiling point is determined by the pressure in the evaporator. For most air conditioning systems, okay, that are air based, I want my boiling point to be around 35 degrees. Any hotter, it's not as efficient. Any cooler, it might cause ice to form on the evaporator coil, and we don't like ice in air conditioning systems. So the boiling point is determined by the pressure of that evaporator. There's a temperature pressure relationship. This is an example of an evaporator. Okay, it's called an A coil because when you look at the side of it, it sort of resembles an A. Air blows up through the evaporator from the bottom to the top and then out through the ductwork into the house. Every system has a high and a low side. Okay, the division takes place between the compressor and the metering device. Those are my 2 points of pressure change, my compressor and metering device. On the condenser side of it, it's high pressure. On the evaporator side of it, it's low pressure. Okay, so when we take a look at this system layout, okay, everything from the compressor to the metering device on the right side, that's the red side of this, is high pressure. Everything from the metering device to the compressor on the blue side is low pressure. Okay, and then if you take a look at that line, you see that line that's showing that blue line that's in the middle. Okay, now we also have change of state. So we have 2 points where we have a change of state. Okay, we have the bottom portion of this, about where the red ends, all the way over to the right through the evaporator, is liquid. That's why it's called a liquid line. The top portion of this with the compressor, the top half of the system, when you look at this, is all vapor. Because remember, the compressor is a vapor pump. Okay, so we have, again, four sides of the system. We have our one that we just looked at, high and low, and then we also have the liquid and gas. Okay, you got to know these. So we have a mechanical sequence that happens in a refrigeration cycle. And again, if you can refer back to the handouts, you'll be able to follow along with this. So starting with the outlet of the compressor, which is right here. Okay, the outlet of the compressor. Okay, we have a high pressure, high temperature vapor. It goes out the discharge line to the condenser. The high pressure, high temperature vapor travels through the condenser and heat is rejected, causing the refrigerant to change state to a high temperature, high pressure liquid. The liquid travels to the metering device through the liquid line. The liquid is then metered into the evaporator, and due to the sudden pressure change, a small amount flashes into a gas rapidly, which helps lower the temperature. The liquid has begun to change state and is now to low temperature, low pressure. As it passes through the evaporator, the refrigerant absorbs heat as it boils, changing to a low temperature, low pressure vapor. Refrigerant then returns to the compressor through the suction line, thereby completing the cycle. So the refrigerant goes constantly through this cycle. It gets pressure increased at the compressor, increases pressure, that increases its temperature of the boiling point, flows to the condenser, rejects heat outside, okay, changes back to a liquid, is cooled down further for subcooling, comes back to the metering device, okay, goes into, becomes a low pressure, low temperature flash gas, moves through the evaporator, absorbs heat, boils off, returns to the compressor as a vapor, superheated vapor. This process does not end, and the refrigerant is never used up or destroyed in this process. You do need to know for everything you do in refrigeration, all your troubleshooting, all your conversations with technical support, you have to memorize the refrigeration cycle.